plugging them in because it makes life easy, right? So your the last one is find the correlation between x and y. So they typically use rho to stand for correlation. So we want rho is x, y, is the correlation between x and y, which is equal to the covariance of xy divided by the sum of the divided by the square root of the sum of the variances, right? Now let's take this down another step, right? We have what's called the covariance computing formula, so we can just plug that in. So we know that this is just going to equal the expected value of x, y, so x times y, minus the expected value of x times the expected value of y. And then we can divide this by the sum of the variances. So we're going to come back to this here in just a minute. And what we're going to do first is we're going to compute all these things. So let's first compute the expected value of x. So to get our expected value of x, we're going to take our x value and times it by our marginal. Same thing over here and here, right? So we're going to have 1 times 0.32 plus 4 times 0.32 plus 8 times 0.36, right? So we just have our x value times it by the marginal. So 1 times 0.32, 4 times 0.32, and then the 8. When you compute that out, you should have equals 4.48. And since we're sitting right here already, let's do our expected value of x squared, right? Because we're going to have to compute our variance. We have that variance computing formula is equal to the expected value of x squared minus the expected value of x, right? So let's just compute our x squared. Now what we're going to do is we're going to take our x value, we're going to square it, and then times it by the marginal. Same thing here. And since we've already got it all written out over here, it's very easy just to write 1 squared times 0.32 plus 4 squared times 0.32 plus 8 squared times 0.36. And when you compute that out, you should get 28.48. And then from there, we just plug these numbers into our variance computing formula to find the variance of x, which is going to go in right here, right? So we're going to have variance of x is equal to 28.48 minus 4.48 squared. And that should just give us 8.4096. Then we're going to do all the same thing with all of our x's, our y values, right? So let's find the expected value of y. We're going to take our y value, which is 2, times it by our marginal, which is 0.52. And then we're going to do the same with our other one. Take our y value, times it by the marginal, 0.48. And that should equal 3.44. Right, and then same thing, we're going to compute our expected value of y squared. We're going to do just like we did on our x squared, right? We're going to take our y value, square it, and then times it by the marginal. So we have 2 squared times 0.52 plus 5 squared times 0.48. And that should equal 14.08. And then we have our variance of y. It's just going to be 14.08, right? It's going to be our y squared. and we're going to subtract our expected value of y, 3.44. We need to square that amount, and that should give us 2.2464. Then we have one left piece. So if we look at our correlation, right? What can we fill in right now? Well, we don't have our x, y, right? So I'm just going to leave a box here for right now. We can take our expected value of x, right? 4.48. We know our expected value of y, right? 3.44. And we have our variances. That's a square root, right? Variance, oops, we don't need to write that. So our variance of x is 8.4096. We can take our variance of y plus 2.2464. And now all we need to compute is this value right here, expected value of x, y, right? So same thing. What we're going to do is, let's block this out, expected value of x, y. So to get our expected value of x, y, what we're going to do is we're going to take our x value and our y value, x value, y value, times it by the marginal, right? So we can, let's see if I can do it from over here. Take our x value and our y value, times it by the marginal. So we're going to have 2 times 1 times 0.11 plus 4 times 2 times 0.24, 8 times 2 times 0.17 plus, and then we're going to 5 times 1 times 0.21 plus 5 times 4 times 0.08 plus 8 times 5 times 0.19. So all we did was we took our x value, our y value, times it by the marginal. X, y, marginal. Same thing here. X, y, marginal. X, y, joint, sorry. X, y, joint. X, y, joint. X, y, joint. And then once we sum all that up, we should get 15.11. And then we just fill that in over here, 15. And then once we compute all of that out, we should get a value that's negative 0.0923. So this would end up being your correlation. Hope that makes sense. So in a sense, what we're doing is first you want to attack this problem with the correlation. First, make sure you have all your marginals computed, right? You got to know these variance, know these computing formulas, right? This variance computing formula, you should have it memorized. This covariance, which is just this. And then correlation, which is covariance over the square roots variance. One thing I will show you that you may want to take a look at, right, is right here, right? So this could possibly help you out quite a bit, right? Is if the problem states, right? So I hope you got this. I'm just going to fill you in with something else that's going to come in kind of handy for you to take a look at, and it'll help you real quick with computing the correlation and the covariance, right? So you have, let's say we have the covariance, right? Covariance formula of x, y is equal to the expected value of x, y minus the expected value of x, So if the problem starts out saying that x and y are independent, so if x is independent of y, right? So if x and y is independent, we know that this right here, if this is true, then we know that we can push this expected value into each one, right? So we know that if they're independent, we can rewrite this as the expected value of x times the expected value of y, which then, to finish out that covariance formula, right? And this right here, that's just equal to 0. So if the problem starts out saying, hey, they're independent, you know that the covariance is going to be 0. Well, what do you know about the correlation, right? So correlation is covariance divided by the variance. So you're just going to have 0 divided by some number. Let's just put, I was going to put x, but let's just say this is z, right? Some value z. Well, if we know they're independent, we know that this is just going to be expected value of x times the expected value of y, subtracting itself, which is 0, which also makes this 0. So there's just a quick little shortcut that you can use as far as reasoning when you go to do some of this for your homework. I hope this stuff makes sense. If it doesn't, let me know. I'll try to clarify something.